This
missed all this.
conference will now be recorded.
Yeah, no issues. Got it right. This is the idea about constructors. Why do we need them? They are used to initialize, declare and initialize instance variables. They are called automatic whenever an object is created. Now you can test these examples. Can you see here now? I took a constructor, declared and initialized instance variables, and then I'm printing in the method instance methods. Now we have separated the responsibilities. Constructor to declare and initialize instance variables, and method to print instance variables. And now we created object and then we are printing it. When this object is created, this init method is automatically called. That is the magic. Maybe if you doubt it, test it to see this will get executed. The proof is if it is not executed, you cannot call this self.name in the display function. You cannot call this instance variables in the display function. What is that? That self.name, self.author, self.price. It's not possible for me to call this instance members without declaring and initializing in the init method. So when this is called, when object is created, automatically, when this is executed, automatically object is created. When object is created, automatically constructor is called. And the initialization, declaration and initialization is automatic. You can test this code set, all of you. Okay. Now you can run it once and see the output. Can you see here now? Now means what? Is this init method called or not? Suppose you change it to init one, see if it gets executed. This is a method, not a constructor anymore. Got it right? So you try to execute it now. See here, you got errors here. Why? Because without executing this method, it's not possible. It's not possible to call this variables here. Because variables are declared and initialized only when you call this method. This is a clear proof. If it is a method, we should call it explicitly. If it is a constructor, we don't need to do that. Okay. If this should get executed, I have to call it explicitly saying something b dot like this. Okay, now this will work. Can you see it now? But if it is constructor, what? You don't need to do this like this, because if you see, remove this one. By default, this is what? This is a constructor. Now when you run it, what happens? At the time of creating object, this constructor is automatically called and these variables are declared and initialized. Then when display is called, it will, we are able to call these variables. Got it right? That's the simple idea about the constructor, default constructors. Can you test it? Take a minute and test this course. Just take a minute and test it. Come on. Okay, right. So if testing is done, then you can try this also, parameterized constructors. You have parameters like this. Can you see it now? Same like parameterized methods. For a parameterized constructor, anyhow, constructor means by default you have to use underscore, double underscore at the beginning and ending of this, and and you need parameters like this. Okay, and usually this is most used approach than most of the time using default constructors. Okay, parameter passing is the most used kind of approach people use. Right, next, you got it right. How to declare it? So this is the syntax. Usually it has parameters like this, and then it has underscore at the beginning and ending, and also, and you do the initialization inside this constructor. Declare and initialize. The instance variables are initialized with this local variables. These are parameters, right? We initialize through local variables or parameters. And while calling, now how do you pass values to this constructor? At the time of creating object, we pass values to this parameterized constructor through the object like this here. How to pass values through this object? How many other parameters are there? That many values you should pass through this constructor or through object. Suppose if you have two parameters, then you should pass two values. Which values you want to pass? It depends on your requirement. Suppose if you want integers, pass integer. If you want double, pass double. If you want float, pass float. Got it right? So this is a simple example, a book example. We're just trying to initialize book through what? Through parameters. Okay. And here I am taking three variables, name, author, and price. To initialize these three variables, I am declaring three parameters here are local variables. You can assume as any of these ones. Okay. Name, author, and price. Both are having similar. This is a standard custom. It doesn't mean that the instance variables and local variables should be same or parameters should be same, but it is a standard practice. Now we are initializing this parameters or local variables to instance variables here. Can you see? The right side of this assignment are local, left side are instance. Now you can see while creating object, you can see here, I created two book objects. We have an opportunity to pass different values to different objects. For first object, I passed AA, BB, and 700. And for second object, I passed VV, something like this. You can see the advantage of parameter passing is to each object we can pass different types of values, different values. Suppose in the previous example, the disadvantage is these values will be same for all objects. If I create 10 objects, all the 10 objects might hold same details. Harry Potter, J.K. Rowling, and 1000. But suppose if I go for parameter passing, then I have an opportunity to initialize each object with different values. See here, if I create two objects, I can pass or I can initialize each object with different set of values. So this is the advantage what I have with the parameter passing. Okay, guys, can you hear me? Hello, hello, hello. Am I audible?
Oh, yes, yes, we can hear you.
Yeah.
Manohar, we can hear you.
Yes, sir. Yes, we are able to hear you.
Okay, okay, fine, fine. So because I see that Madhu has some problem. You guys, just for Madhu, I think, can you hear me, Madhu? Fine. Now, please test this code, sir, all of you. Nothing here, it's a simple thing. We already know most of this stuff because we have done since from past 4 months. No, we missed couple of weeks, not completely. One or two, we used to miss one day sometimes. But most of the time, no, we have worked more on coding. Now, we can easily get all these things. This is not difficult for us. Just test it, sir, quickly. And we get output like this. Okay. You can test this code, all of you. Just take a minute and test the parameterized constructor. Once it's done, just update me. Then we'll close this destructor topic also today. Okay. Then we'll move to the other one. Still, we didn't finish it. Here I am adding one more thing. What is that? Static versus class methods. Next session, we'll talk about the introspection. And then we'll switch to the inheritance. A workaround on these two, how both are different. So then we'll finish off this and then switch to inheritance. So most of this OOP, once inheritance doesn't take much time, it is a simple topic. Okay. From here onwards, hardly we can finish most of the topics quickly. So finally, we have finished functional, and then maybe some regular expressions topic is there. We need to discuss that as well. So do you guys miss any audio while explaining this? Seems like I missed something while talking about parameterized constructors. Or okay, thank you. Take a minute and test it. Then okay, sir, test it. Finish testing this. You want some time? Just a couple of minutes. Some more time. Okay, shall I move to the next topic? Destructors. It takes quickly, doesn't take much time. Is it done, sir, all of you? Okay, thank you. Thanks for the confirmation. See, destructor is something, opposite to constructor. Correct? What constructor does? Without constructor, we cannot create an object itself. Okay, you can see here. No? Do you get it? Means, and also that constructor will initialize the state of object. State means what? Usually object look like this. When you create book object, book object will be initially, when you create object, it will be like this initially. It has some address. No, we have discussed all this in the beginning as well. And this is initialized to some variable, instance variable. Assume that it is b, some 100. And this b is referring to this object. Correct? Is referred by this object. We will be referring to this. Okay. And so far in the beginning, it doesn't have anything inside. Okay. But once you try to call constructor, when constructor is called, immediately these variables are declared inside object and they are initialized. Like how now this has a, now here if you look at it, this has name inside this, author and the price inside this. So when constructor is called, adding of variables happens and then initialization immediately happens. Because why? Both are happening same time. Here you can see. Declaration is this, initialization is this. So that's why you have variables like name, author, and price, and some values, something like you are giving some, you are passing something like a, something like BBB, something like that, and some price. This is what happens when constructor is called, right? What constructor does? Your object creation, your object initialization. Initialization means these are called states. These variables can also be called a state of object. This instance variables. And who is doing that? That is all that is done through constructor. At least that creating object will happen only through objects. Maybe to declare and initialize instance variables still you can do through method. That is possible with method also, but constructing object happens with the constructor. Similarly, destructor means what? Destroys objects. What it do? As name says, it simply destroys objects. Usually there is something called garbage collection or cleanup operations. It's like, removing unwanted objects from memory. Suppose you have done using some objects, creating objects, performing operations on them, and the execution is done. Still, that objects exist in memory, and you want to clean that. You don't want it to be there immediately. You can do it with the destructors. Of course, even if you don't call destructors, it is automatically done. You don't need to worry about it. Python has its own garbage collection mechanism, like how Java has. But still, you can also do this cleanup operations explicitly by using these destructors. You get it right? The point is what destructors does here. It is used to perform. This is how, first of all, the syntax look like this. Similar to constructor. If construct uses init to create to declare constructor, destruct uses del. Hope you remember this del has some connection to you somewhere in Python. Do you remember? Can anybody tell me where we use del? So anybody tell me where did we use this del? Del is it is a keyword which is universally applied to delete anything, any kind of, to remove or delete any kind of object in Python. To remove value types, to remove reference types, to remove collections, to remove everything, not just lister. My dear Deepak, you can see here. So here, let us just use command prompt so that we can quickly test it. And also you can see the a equal to 10, print a. Now you say you can just delete this as well, del a, then now you print a, you get an error. Why? It deletes that. Suppose you have a collection, as you said, a equal to some list of 10, 20, 30, 40 like this. Sorry. It takes only one object, right, at a time. So we have to say like this. We should use the square brackets. Okay, enough. Okay, print it. Now you say you can remove some specific element from the list permanently through del, or you can remove that collection itself permanently with the del keyword. In that way, del can be used in different ways. I can say del of something like a of someone, and then you see here that is removed permanently. Suppose I say del of a, and what happens now? Now that collection itself is removed permanently, like that. So similarly, this del key, here also to do this, create this destructor, this Python people used del here. And before that, we have, at the beginning we should have double underscore, and at the end we have double underscore. That's what this is, how we create a destructor. Okay, it is used to perform garbage collection. That is one thing. Second thing, what is garbage collection means? Just removing unnecessary objects. We don't need to do that. Already we have discussed these points here. It is done. Even if you don't use destructors, garbage collection happens in Python. And like constructor, even destructors are automatically called. When it is called, observe this point carefully. Once after the completing execution of a program. As the program execution is done, then destructors are called automatically. And another important point, when an object is eligible for garbage collection, means if object doesn't have external references. What do you mean by external references? See, as long this is a reference, B is a reference, B2 is a reference, as long as this reference is there for object, these are not eligible for garbage collection. Once the references are removed, means when they get removed, once the execution of program is done, then the references get removed, or otherwise you have to nullify them. You can do it in two ways. Once the execution is done, or either you nullify them. Are you following, gentlemen? So in that cases, we don't have external references. But as long as references exist to objects, they are not eligible for garbage collection. It's like this. Going to a hotel, as long as you sit in front of a plate in that hotel, that plate is not removed. But once you go out for a half an hour and come back, do you think your plate exists there? By default, it will be garbage collected. Server will come and do this collection. Same thing happens. Means if reference is there, object is not eligible for collection. Garbage collection. Otherwise, what happens? If reference is not there, then it is a garbage collected. And we have two types: implicit and explicit. Implicit, we don't need to do anything. Your interpreter will take care of it. We don't have any involvement in it. Explicit means we do that. How do we do that? By declaring this del, this destruct in the class like this. This is a quick example just to get a quick idea. We don't need to, just a quick test here. Create a destructor like this and create some objects like this. And once the execution of program is completed, you can see that this destructor automatically called and it performs instant garbage collection on that. Obviously, your Python will come and do that garbage collection. But if you put destructor, you are explicitly trying to do the garbage collection. It's like calling to a municipality guy and asking him to come and collect your garbage. That is explicit. Even if you don't make a phone call, he will come and collect. That is also there. That is implicit. Same thing here also. Got it right? Let us just quickly test it. What happens now? So, if you look at it, just run this. Now you can see I didn't call any destructor in the program. Once the execution is done, it started calling object destroyed. And you can see, if you observe carefully, this object destroyed called for how many times? 5 times. And which object is destroyed means still you can print that still it is taking self. See there, it is taking self. Can you see it now? Means now you know which object get destroyed also if you want. Now run this. Can you see that? When you print self, that gives you an idea which got removed. Got it right? Maybe if you want to know, just print those references and see which is what, which is holding which object here. What is A1, what is A2, what is A3, what is A4. Now this is a clear idea. As soon as execution is over, these objects are garbage collected. Here I am doing that through destructor. Got it right? So test it, sir. Just take a minute and test it. Today we missed most of this starting session. The recording is missed for this one. We'll see if we can if we have any backup videos. I will add that to the. Okay, we will do the conclusion for that workaround for static versus class methods in the next session. Okay. Finish this, sir, all of you. Is it done? Clear now? Nice. We'll continue tomorrow. Tomorrow, in sense, next week, we'll finish off this anyhow. So I put it here so that if I might forget, not make sure that to remember this is here. Once we do this, then we go to the inheritance. So, any questions, sir? All of you are clear for today in today's session. Madhu, any questions? Anybody want to add more to this? Any deeper questions on this, so that might be we can get more opportunity to explore more into this. Anybody can add anything? More than these are just training programs. You can take them as brainstorming sessions. Brainstorming means even you can also come up with questions and we can discuss. We can add more to this this thing, to the content, so that it helps many people, not just us. When you upload to the YouTube, when will we start NumPy? NumPy, when we start data science sessions, we'll start NumPy, Vinod. It takes time. We have to finish a few more, but we are almost at the end of Python. This advanced Python, inheritance and polymorphism. Next week we can finish these topics. The point is, we might think that, but suddenly, some kind of workaround comes. Then what happens? We'll be trying to learn more on that. I'm not saying that it is it's very useful. It is not like we are spending unnecessarily. Probably this doesn't take much. These are all more like object and class concept, class and objects, something, and few more extra observations and regular expressions. We can finish it this. Okay, and we can add more to the point. That's all. And threading. This doesn't take much time anyhow. Okay, we might plan, might be probably within couple of weeks. Okay, some. And also database connectivity. If you wish, we can learn this also. How we connect to the database and okay, that will end this advanced Python. And we can start NumPy and Pandas, Vinod. Got it? So that's all for today. So no questions, right? Any more questions from anyone? So all of us are good. Okay, fine. So probably we will continue next week with this. We'll start with this and do a workaround on this, get some conclusions, and then we'll switch to inheritance. This doesn't take much time. Inheritance, polymorphism. Okay, this when we can finish it quickly next week, and then okay. Thank you guys. Have a weekend. Good weekend. See you.